Alright, so here's the video for electrochemistry. I'm going to go kind of fast because we've already went over this. This is just for like a really quick review if you guys want to study this. So, electrochemistry. Electrochemistry, it's the study of basically chemicals and how they change electrons. It's basically the electrical energy and how it interacts with these molecules. So, remember, if you get stuck on the test, oxidation is the loss of electrons. So, oil. So oxidation is the loss. Oxidation is losing electrons, and reduction is gaining. R I G. So basically, there are two types of cells. You have galvanic cells, which produce electrical current. This is when one is being oxidized and one is being reduced, and the electrodes are flowing from the anode to the cathode. I'll get into all that later. This is what a battery is. This part here, this is stuff that HL needs to be able to do. And then electrolytic cells are ones that use electrical energy to basically split up a chemical, or in this situation here, which is the same exact thing but reversed. You can see this is for HL. Same equation but just flipped around here. This is how you basically are charging a battery. We take the equilibrium and we reverse it by putting electrical energy in, basically putting all the energy onto the anode again so that those electrons can flow back through and over to the cathode so that battery gets recharged. In this situation, you do need basically you need to add in power. So keep that in mind as well. The galvanic cell. The anode, this is where the electrode, where the oxidation occurs. The cathode, this is where reduction occurs. Oops, that shouldn't say anode. This should say electrode. Remember, the cathode is going to grow and the anode is going to shrink because those ions are going to go into solution. Cathode is going to grow because those ions are coming out of solution and turning into a solid. The salt bridge is going to allow a neutral salt so that the flow can, basically the anions can go where they need to go to keep an electrical balance. And remember that the electron flow goes from the anode to the cathode. This is what it looks like. This is what your book will show you as well. Remember this, so over here I have my anode. The electrons are flowing from the anode to the cathode. This is going to shrink this little electrode here. You can see that right here where they're going into solution, and then my cathode is going to grow more massive because these ions are going into a solid state again. You can see that right down there. This little diagram, it's just a good picture to show you what's actually happening. I know we've talked about it before, but this is just a visual aid that maybe that'll help you out. In this situation, remember, you do need the salt bridge. So when you are asked to draw this on the test, which is going to happen, you are going to be expected to be able to draw this. Do not forget the salt bridge. Do not forget it. I'm not totally positive if IB on the mark scheme would take you off for it, but it's just good chemistry. It's just a good habit to get into. You need all the parts of the cell. Okay, and then the next one that we have is electrolytic. Remember, these need to be in solution, or in other words, in an aqueous state, or liquid state. That's why we're talking about molten sodium chloride. It's not NaCl that has been put into water, but rather heated up to the point where it's gone from a solid to a liquid. Here what we have is the battery, where we are going to be adding in energy. We're going to be adding in, sorry, not energy, current. the electrons flow to the cathode, which is the negative terminal, but we still call it the cathode, because remember, a good way, Lars, the way he put it, is the cations of the cathode go and turn into a solid. Remember, this is also where you're going to have a lot of electrons built up around the outside, and those electrons are going to jump onto the sodium and turn into the solid state sodium. And then the anion over on the anode is going to donate electrons, becoming the elemental state, and those electrons then flow back up into the battery to complete the circuit. In this situation, they have a barrier up. It doesn't really matter. It could be in a single state. You could have a barrier set up as well. I would say don't put a barrier, but it doesn't really matter. The reason why this barrier is okay is because it's porous, so that the ions can go through it. I would say just make it into a single system. Whatever way you want to do it is fine. So remember, the electrons go through the wire. The electrons are going to the cation, and then the anion is going to donate electrons into the anode. If you are struggling to figure out the difference between the galvanic cell and the electrolytic cell, just remember the electrolytic is in one big situation, like one, it's not two separate cells, but rather one. I would say label it all like you would normally, and then you can just kind of switch the names. So in for example, I'll just do this again. I'm going to set up a really bad galvanic cell. There's my cell bridge. If this is a galvanic cell, galvanic, and then I'm going to call this my anode. This is going to be my negative terminal and my positive terminal. Electrons are going to flow this way. You can do it all the same, but just remember, in this situation, this is my anode, and over here would be my cathode. And then you can see it's the same up here, except in the electrolytic cell, the notation is reversed. So you can keep the negative and the positive the same, because you're going to have, just remember to flip around your negatives and your positives. Your negatives are still flowing from your anode, your electrons are flowing from your anode, but then just you can switch around the signs. I know Akmal does it where he does it all the same and then he switches around the names. However you want to think about it, just remember that the notation is reversed. So over here, the anode, like in the galvanic cell, the anode is the negative terminal, and the cathode is the positive terminal. In an electrolytic cell, the cathode is the negative and the anode is the positive. That's like the big difference between them that everybody gets mixed up on. Okay, so then this is just an example, a drawing of what an electrolytic cell looks like. So what we're doing here is we're basically adding in NaCl solution. So what we have is NaCl in solution, aqueous, within water. We can see that the chlorine is going to be donating these electrons to the anode, and then from that it becomes chlorine gas, elemental chlorine. In the cathode, what we have here is we have two options of what is going to be reduced. We have Na+, and we also have water. Based on where they are in the electrochemical series, you're going to just see which one of these is easier to reduce, is a good way to think about it. You can kind of reverse the activity series when you're looking at this. What ends up happening here is because water is easier to reduce, in this situation you're going to notice that the H2O splits into the hydrogen gas and the OH minus. So what's happening here is you have the oxygen is actually going to be reduced. So oxygen is reduced. And then from that we end up with sodium hydroxide, and then we release hydrogen gas. So this is just looking at the electrochemical series. And we're just looking for HL. You're just looking at the reduction potentials. Whichever one is lowest on that list is going to get reduced first. Excuse me. Okay, so then if we're looking at a situation, we're trying to figure this out. The cathode is going to be completing two possible reactions. You're going to have Na plus going into sodium, like sodium state, or water being reduced into this H2 and OH minus. Since this is going to require less voltage, this is what is going to happen in the system. Those electrons are going to flow to the oxygen, producing this option. And then the same thing happens here, where you're having two options. You can either reduce the chlorine, or you can, you can oxidize. Why aren't you working, pen? There it goes. You can oxidize either the chlorine or the water. In this case, you're going to also be picking, you're going to pick the one that is more negative. And it still follows the same ideas of which ones are able to donate electrons and which ones are able to accept electrons easier, or which ones take the least amount of voltage. So you might end up having to pick one of these, like which is going to happen. And then we've talked about, like, there was a couple of multiple choice problems on this for HL, so it's the same exact idea. There are multiple choice problems on that, the oxidation reduction packet that I gave you for practice work. So, and then you have a nice little explanation down here. I'm going to quick go on because I don't want this to be super long. Okay, so then cathodes and anodes. The cathode of an electrochemical cell is the electron. Man, excuse me, I'm getting a little sick. Is the electrode at which reduction occurs. So this is where you're going to be adding in electrodes. The anode is going to be where oxidation occurs. So this is where you're going to be donating electrons. That's supposed to be a minus sign, whatever. Donating electrons. And this is all stuff that we've gone over before, so this shouldn't be anything too new for you. When you're setting up a standard notation, remember that the anode is on the left, so you're going to have the electrons flowing to the right. And this is all stuff that we've talked about. I've showed you guys this before. Like standard cell notation. It's basically just the idea that the zinc is turning into zinc 2 plus and the copper is turning into copper solid. It's just a different way of writing it. I've noticed IB asks more for the half equations rather than this line notation, but I figured I'd show it to you again just so you could see it again, maybe refresh it one more time. But yeah, this is it, really. There are other things that you might have to do. So, like, if you have NO2 and something happens so that it turns into NO, it might ask you what is reduced here. And this is where you kind of just need to look at it and be like, okay, well, oxygen is normally -2. Oh, this pen is acting up today. Oxygen is normally -2, which means in this situation, nitrogen would be +2. Or here, this would end up being, nitrogen would have to be a +4. So nitrogen went from a +4 state to a +2 state, so your answer would then be nitrogen. In this situation, neither of the oxygens have been oxidized, so there would have to be something else within this equation that was getting oxidized, just because of the law of conservation of charge. So this is electrochemistry really in a nutshell. I would say If you know how to draw up the cells, both of them correctly, if you know how to figure out what's going to be produced, if you can answer these questions based on the state of the charges like this, you can diagnose state of charges, and then don't forget to maybe do, before I see you guys, maybe one Winkler method question. That'd be a good thing to review as well, but remember that's still just the 4-to-1 of the SO, no, I can't remember it off the top of my head, the SO3, and diagnosing what the BOD is, the biological oxygen demand in water is. So yeah, this is just a really quick review to help you guys study one last time. Good luck on Monday, and I'll see you guys soon.